In this video, we're going to revisit TCP and UDP, which we discussed earlier in our section on the OSI model, and when we talked about specifically the transport layer. So in this video, we're going to spend an entire lecture talking about the specific details and differences between TCP and UDP. So as a bit of a refresher, TCP and UDP operate at the transport layer of the OSI model, and they provide end-to-end connectivity and reliability when we're sending items over an IP network utilizing a multitude of our different application layer protocols. So in regard to them, TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. Now, one important difference and distinction between the two is that TCP is connection-oriented, whereas UDP is connectionless. So let's talk a bit about the differences. TCP is definitely the most widely used out of the two. When we're looking at TCP and UDP and all the different protocols, a majority of them are going to use TCP because it's considered to be reliable, because it sets up a connection that we call a three-way handshake, and I'm going to demonstrate what that is later in this lecture, both on a slide and also in Wireshark. When we set up a connection, what we do is we provide a means for us to ensure that the delivery of our packets are going to be guaranteed, because there are safeguards in place within TCP where if we have a connection in place with another system and we start sending data back and forth, if for some reason we don't receive a packet or if it's corrupted, then it'll retransmit it. It'll ensure that it's sent to us. So that guaranteed delivery is really what stands out for TCP. Now, in regards to UDP, it's considered to be unreliable because it doesn't set up a three-way handshake. It's connectionless. I simply say, hey, can you please send me this? And the server says, okay, here you go. Here's everything. And it doesn't have any sort of safeguards to ensure that I received it and that it was intact. But that's not always a bad thing, because UDP is often used for things that are either streaming or real time, where if you retransmitted it, if it's real time, well, it's going to be useless because we can't go back in time. For example, if I'm on a phone call utilizing voice over IP, well, if for some reason we have maybe 2 or 3 packets that are dropped because of a bad connection, we can't go back in time and retransmit those because it's a real-time conversation. If we tried to, it'd be very odd. Can you imagine if I was talking to you and all of a sudden, over top of me talking, we're transmitting older audio? It really wouldn't work. So UDP is often used for real-time data and streaming, specifically audio streaming and video streaming services, as well as some other things. So with that said, let's take a deep dive look into TCP and its reliability. So let's talk about specifically how TCP provides reliable delivery of our data. Well, the first one is something I already mentioned, that is the three-way handshake. And again, we're actually going to look at this in much more detail on the next slide, as well with a live demo within Wireshark. So before any data is exchanged, we create a virtual connection that is called a three-way handshake. And that's that connection that is created that I talked about on the last slide. Additionally, whenever any data is sent, we must acknowledge that we received it before the next segment is sent. And remember, when we're talking about the transport layer, we're talking about segments of data. We break our data up into smaller chunks that we call segments. Also, there is something that's called a checksum. So when we receive it, we can run a checksum against it, and we can determine if that data has arrived intact or corrupted. If it arrives corrupted, then we can ask to have it retransmitted. So with TCP, we can retransmit any corrupted data or any that is lost as well. And in regards to something that's potentially lost, well, there are those sequence numbers that I mentioned earlier when we were talking about the transport layer within the OSI model. So when we send data over, they're given a sequence number, and if for some reason we don't get one, then we can use that to also have them transmitted. So those are the ways in which TCP provides reliable delivery of our data. Now, one thing that I do want to mention is that when we compare TCP to UDP, the header specifically for the segment is going to be much larger for TCP than it is for UDP. So the TCP header is 20 bytes in size, whereas the UDP header is only 8 bytes. So it's going to be much larger, and that's why UDP is considered to be lightweight, and faster than TCP. So let's go ahead and let's take a look at the three-way handshake. So the three-way handshake is pretty simple. The way that it works is that we send what is called a SYN request to the server that we want to communicate with, which I have depicted here. So let's say that this is a web server and I want to request a web page from it. Well, to start that communication back and forth, we have to establish this three-way handshake. So I start off by sending a synchronization request, which you'll typically see as an SYN. Then the web server, they'll respond with an acknowledgement to that saying, hey, okay, we received your SYN request, here's our acknowledgement. And then finally I say, okay, I acknowledge that I received your acknowledgement. Once these three steps take place, then we can start sending data back and forth. But these three different steps have to take place first successfully before we can actually start sending data back and forth. And that's what the three-way handshake is. Now let's go ahead and let's actually take a look at this in Wireshark. So to demonstrate the three-way handshake, I went ahead and loaded up one of my virtual machines, specifically one of my Kali Linux machines, because I have Wireshark installed on it. And Wireshark is, if you look up here, it's a network analyzing tool. Specifically, it's a network packet capturing and analyzing tool where we can set it so it's going to capture all the packets that come through a network interface card interface. And we can turn it on, we can turn it off, we can do all sorts of filters. What we're going to do with it is that we're going to tell it to listen to my Ethernet network card. So this is the one that's going to be going to my wired network, and anything that is TCP, I'm going to filter for that. And we're going to look at the three-way handshake. So to get it started, I'm just going to double click here. And now you're going to notice that this turned to red and it says click here to stop capturing packets. So that means that we're currently capturing packets on my Ethernet interface. So now what I'm going to do is I'm just simply going to open up Firefox. And now in regards to finding the three-way handshake, we can either scroll through all these. There's 670 of them. Or what we can do is go up to the top and you're typically going to see a three-way handshake at the top, or we can even go a bit further and we can type in a filter, and we can type in a filter simply for TCP, and it's only going to show things that are associated with TCP. So let's go ahead and get rid of the filter because we already have one at the top here, and this is going to show us our three-way handshake. So what you're going to notice, and let me get my highlighting tool ready, is that we have a source IP of 192.168.0.8. That's going to be my machine. And the destination is going to be the web server for my website, which is going to be 34.107.221.82. So to establish this three-way handshake, my system sends a synchronization request to that web server. And then on the second line, the web server responds. So the web server is now the source and my IP is the destination. They provide us that response, that SYN-ACK response, step number 2 in three-way handshake. And then I go ahead as the third step, I then respond to them as a source, to them as a destination, an acknowledgement that I received their three-way handshake. And then after that, we can start sending data back and forth. So that is the three-way handshake. That's our live demo. Let's go ahead and now let's take a look at UDP. All right, so now let's talk about UDP, which I call the best effort protocol of the two. So we know that TCP is great, but there's also UDP. And when we think about UDP, we can think of it as being a scaled down and more economic version of TCP. It's connectionless, meaning there's no three-way handshake, and therefore it's considered to be unreliable, which always isn't a bad thing. It doesn't provide any sort of data retransmissions, so there are no sequence numbers, there are no acknowledgement numbers. So if something is sent to us and we don't receive it, or it's provided to us in a corrupted manner, well, it's not going to be retransmitted. So because of all of this, it's considered this best effort type of a protocol. But when we think about TCP and UDP, TCP, yes, it's more robust, but UDP is faster than TCP for a variety of reasons. Number one, the header is much smaller. So remember, when we're looking at the two, the TCP header is 20 bytes, whereas the UDP header is only 8 bytes in size. So in regards to the data itself that's being sent over the network, It's going to be smaller, so it's going to be faster. Also because it doesn't have to set up the three-way handshake before it starts sending data. It's also going to be faster. So in regards to UDP, all that really has to happen is that you can request some information, some data, and then the server or whoever you're requesting it from, if they utilize UDP with that protocol, they just start sending it back to you with no sort of a connection set up. And in regards to UDP and talking about the specific type of protocols that is typically used with, well, like I said earlier in the lecture, it's used with a lot of real-time and streaming type of protocols. And if you remember from our earlier lecture, we looked at some of those different protocols that it's used with. And you're going to notice that it's also used with a lot of network management protocols where performance is more important than reliability. So when we talk about performance, we're talking about speed. So things like DHCP and DNS, they use UDP over TCP. And then also the obvious things that I talked about earlier, voice over IP, video streams, audio streams, online gaming, real-time type of stuff, they also use UDP. So that's UDP. Let's go ahead and let's take a look at UDP in Wireshark just like we did with TCP. Alright, so we're back on my Kali Linux machine and I already have Wireshark up and loaded for you. But to demonstrate the use of UDP, we're actually going to use terminal and we're going to do a name server lookup. So NS lookups use DNS and DNS uses UDP. So what we're going to do is we're going to go over to Wireshark. We're going to double click on Ethernet 0 and get it ready to start capturing packets. It shows this in red, which tells us it is capturing packets. So now what we're going to do is we're going to type in NS lookup and we'll just do google.com. We'll type that in. You're going to notice that we have some DNS stuff here. So what we can do is we can stop Wireshark. We can maximize it now. And what we can do is we can take a look at DNS because DNS uses UDP. So there is a query and then there is a response. There is another query and there is a response. You're going to notice there's no three-way handshake. My system sends a DNS query to an IP address of 8.8.8.8, which is the name server or the DNS server for Google. And Google's DNS server responds to me. There is no sort of a connection set up. So if I inspect one of these, if I double click on this one, what you're going to notice is that it uses the user datagram protocol. So it tells us that we're using UDP. And it's as simple as that. When we have a protocol that uses UDP, well, we send a request and it sends a response back to us. There is no connection set up. So that's our quick live demonstration looking at DNS and how DNS uses UDP with Wireshark using a basic NS lookup command, which is a name server lookup. So if you wanted to look up the DNS server, or in other words, DNS is the same thing as name server for any domain, you could simply type NS lookup and the name of that domain. So that's going to go ahead and conclude this video and our discussion on TCP and UDP. If you have any questions, please let me know. If not, thanks for watching and I'll see you at the next video. Take care.